Okay, so welcome back. And now we're going to make a transition. And the transition of concept is from static classes to objects. And the aim here is to show how we work with objects doing actually very similar things to what we've defined in static classes. This again is a very, very important set of transition concepts to help you properly step into object oriented code. So don't simply say, oh no, they're not relevant, let's skip this, let's move straight to objects. For those who are new, this is actually, I hope, going to guide you. So first of all, let's just be clear about the concepts. We said for static classes, they have no state. They can't store videos. They can't store videos as well. They're not even a video store. They can't store data, is really what I was trying to say. I was thinking of a video store example then. There is a really crucial element, a concept I'm going to mention in a minute. You can only have one working version of this. Now that's an interesting concept. Okay, you have one working version. When we look at objects, let's do the parallel, have states. So they instantly allow complexity to grow, right? Think of a multiplayer game. If you have 10 or 15 characters in your games, different weapon loads, different statuses, all of their statuses are stored as a state of that particular bot or player. So that's where the complexity comes from. If you can't store the state in a static class, that won't build your multiplayer game. That will. Okay, it is crucially because objects can store data. You don't always want them to, because you sometimes use objects as components, like the scanner. Scanner is a good example where you're not storing data inside the scanner, you're using it to do some stuff. With a static, you only have one working version. With objects, you end up with multiple working versions, or instances, as we say. Right now, straight away you're glancing at these two and thinking, yeah, that's so clearly better than that. But don't forget the static class in your suddenly recognition that objects are more powerful, and the reason that you're able to play your multi-online role-playing games and all the rest of it you do on your Xboxes, whatever you do. I'm out of date, I don't play games, apologies. It's because of objects, not because of static classes. Static classes go all the way back to the language of C. What else can we say? There's perhaps one of the crucial elements which we'll come to next week, and that's the concept of data. Not only do classes not store data, but there's no logical link between the data that you're manipulating with a static class and the data itself. Whereas for an object, it actually builds a logical structure for the operations on the data you store inside and you hide inside your object, and the operations on it. It logically binds them together. You'll see that next week. Okay, one of the fundamental concepts of building large systems, large complex software systems, is the ability to store data, is for your system to have states, and for you to use one piece of code, a class, to build multiple instances. So they all feed into the growth of software development and engineering as a discipline. So although we started with static classes, and I recommend keeping a static class or console interaction, it's really convenient. It will simplify your main code as you go through this teaching block. You will find more and more that you won't be going back to this because the object is the natural way to do it. Now, there may be a handful amongst you who will simply say, oh yeah, no, but I can do all of that with this, blah, blah, blah. Don't bother about it. If you don't appreciate what the limits of this are as you go through this process, you're going to be wasting your time. You're not going to actually become very good at it because you're going to constantly say, oh, I want to stick to that. No, has its use, but it's limited. Good stepping stone into this. So in these videos, let's do some conversion work, and then we will show you how, very simply, how to use them and what the differences are. And I want you to compare. So what the purpose of the actual code we're going to do in a second is you've built, I'm hoping, console interaction and a calculator from the previous video. If you haven't stopped, go back and do that. Once you've got your static class version, then come to this and slowly watch how we convert them. In the process of converting them, you'll notice a couple of changes. There is an overhead for objects, right? But it's very important you spot what's going on with all these different things. So we're going to start with our calculator. My calculator was really basic. I just had an add in there. I'm just going to add maybe another function very quickly. Let's call that multiply. Let's do a multiply, and let's just simply have a, let's just have a couple. Okay, it's grayed out because I'm not using it in my main code. Right, nice and simple. In order to turn this calculator, notice I'm not using the word static up here in the class. Okay, in order to convert it to a calculator object and use it as an object, I need to remove from this file, this calculator, all the word static, because I'm going to say you are no longer static, right? So I'm also going to change the name of the package, because it's no longer now static class example. We're going to rename that and call it static class to object example, right? That's just for me and conceptually what we're up to. Right, it's first step. Step number one, get rid of the statics. Straight away it will complain, right? It'll complain because we're using it as a static. Okay, so let's go back to where we were using it, and here it had the keyword static, and it had static. It's got that anyway. Let's get rid of the word static there, right? That's the first thing to do, and let's get rid of this asterisk and this dot. Now, a couple of things to note. Why have I got rid of the asterisk and the dot? Because the calculator is no longer a collection of functions. That's all a static class is, a collection of functions. A calculator is going to be an object. So let's use it as an object. The other thing it's complaining about is add. Sorry, I can't use add. What do you mean by add? That's I don't know where add exists. There's no such thing called add. Well, you say, yes, there is. It's over here. So what's your problem? You know, I'm linking to you because in order to use it, I can't use the raw function. That's one of the issues of using objects. You have to have your object. So we need to turn our calculator code, this stuff, into an object. And what we do is this. It's very similar. You'll notice straight away it's very similar to the scanner, what we did with the scanner. You've been creating an object in this introductory material already. So what should we call our calculator? Calc for short. That's the name of this particular calculator object, right? So that is the name of the class that defines the object. That's the object. In order to create it, I use the new keyword, and then I follow it with the name of the class again, open close bracket, and semicolon. Now that open and close bracket at this week will keep empty. We're not going to do anything else other than leave this as this is. Later on, you're going to realize what this is all about. Think of it like this, an advanced concept. It's where you initialize your object. So when you join a game, say in a computer game, you've got a bunch of data related to when you left the game. When you enter and create an object out of you and enter the environment, you need initialization data. That's what goes in there. But because in this example, the calculator is just performing functions, it isn't actually storing data. We don't need to initialize anything in there to store. Okay, so I've got a calculator. Now I'm down here and I'm going to use the add from inside the calculator. Now this is a different concept from using the raw function in a static. In the static setting, I was using that as is. There's a very subtle change. I now have a calculator object, and that calculator object has a visible face. This word here is how you can see the visibility of these methods. See these words here, public? I've not mentioned them before properly. What they mean is that when I create an object, it's visible here when I do this. CALC dot. Notice add and multiply are in my list. Look what happens if I come over here, change this one to private, the multiply to private, okay? Go back over here, hit dot. It's disappeared from my available public functions. It's no longer part of this object interface to the rest of the world. I can't interact with the object or use it because it's private. and it's hidden inside here. Why would you do it, you might ask? Wait, in time you will see advantages and disadvantages, concepts of why you do it. Let's make it public again. Go to here, hit dot. I can use multiply or I can do add. Right, so let's just say I run multiply that, and I'm just going to multiply the two numbers. So these are the only two changes. You have to create the object and you have to give it a name. You have to give it a label. That's your object. That's no longer a class. It's an object. It potentially has a state. Okay, we'll come back to state related stuff later. I can create 10 objects if I want to, and for some of you I can create a second calculator if I wanted to. Obviously in this setting creating multiple calculators is completely and utterly redundant, right? But those two, calc1 and calc are two different objects. They don't share the same data. If one was to store and change its internal data, the second one wouldn't get access to it. They are different entities. Okay, so that's what you need to do to use it as an object. Step one, you get rid of the static words. Come over here, you create an object. You obviously have to link to it in some way. Interestingly, that's now redundant. It's redundant because I'm sitting in the same package as my object. So I can use it. It's quite interesting property. I can use it without having to import it, right? Because when it tries to do this line, it says calculator, calculator. Oh, there it is there. And it's reasonably happy with it. Okay, so let's have a look at it. Then this is where we use it. That's the name of my object. That's the function. Everything else works as before. Output to console, interestingly, is still a static. That's still being used in a static way. So I've mixed up the two concepts. So let's run it. Let's see if this multiplies and outputs. It's asking me for my first number. Let's say 34. Let's say 2. And it says the sum is. It's not the sum. It's the product. Because I'm multiplying them. That's just me forgetting. Let's just run that again. 34. While I do this, please code it yourself. 68. Okay. Got a 0 because we're doubled. Now, I want to make a change to my console functions. Why am I going to do this step? If you're happy with to use statics, that's fine. Leave it as a static. But actually, if you want proper full object-based code, just as you have the scanner object, you would create your own console functions object, which would do the job. Now, at this stage, you might say, but there's no practical difference because their console functions doesn't store anything. Actually, neither does calculator, right? So why turn it into an object and have to do it in this particular way? Well, that's a very, very good question. I'm going to show it to you so you can see it working in the alternative way. And I'm going to, for the calculator, you clearly want to create an object because you'll see in next week's we're going to store data inside our calculator. Before the console functions, you're welcome to keep it as a static. But let's just show you how easy it would be to turn it and use it as an object. Why are objects more useful and more familiar? That's a very big question, and maybe we can discuss that, but we discuss it by you practicing it. At this stage, there seems to be no material significant difference. Right, so how do I do it? I take my static, remove this word static. It's going to be unhappy, output to console. I come over here. I no longer need that import because it's now strictly in the same package. I then create my calculator object and I create, what is it called? It's called console functions. There it is. And I'm going to call it, what's the name I'm going to give to my console function? I might want to call it utils, right? And why have I written configuration? That's a bit, let's try that again. Right, so console functions, there we go. I selected the wrong one. Right, let's do that again, and we'll call it utils, or you could give it a single letter. You could call it whatever you like. Right, your name for your thing, give it a sensible name. I'm going to complete the line with empty brackets because my console function is not storing any initialization data, so this bracket remains empty. I don't need to construct any initial state for my console functions. I might arrive, oops, I might arrive later on when I'm using this kind of behavior. Do not know. Give me a second. I seem to have just wasting my time, and I keep on doing the same thing. Right. Sorry. Right. I might later on want to have initialization data. There might be parameters related to my screen size. There might be parameters related to the type of interface. So having an object for console functions or user in functions, right? User interface relations, right? I might want to change that. So how do I use it? In the same way I did before, I just call utils dot, there's get double, right? And you know, if you're as messy at it as I am, then you just need to kind of that. There we go. The easiest is just grab the utils dot and prefix the name of the function that belongs to it. Go down, there's output to console, and you do it there. Now, slight difference for your console, because you've had to create two objects in order to use it. Now you might say, hang on, that makes my main complicated, blah, blah, blah. Actually, this is the standard way we use object-based coding. We always create objects. This is such a common practice that it becomes second nature to you. But that's not an argument not to do it. And because of the power it then opens up and the flexibility it opens up for you later on as you build more complex systems, you get some very, very powerful payoff from it. Okay, what I would recommend you do at the end of this one is convert all of your console functions and all of your calculator into objects and test it. So hopefully at this stage, you've built some static classes, you've tested them out, you've built then, stripped them and converted them to objects and tried them as objects. You make a judgment whether you want to keep your console functions as a static class or turn it into an object. My attitude is have objects everywhere. Why? Because you just get used to it. It's the most common practice, but there is nothing stopping you using your console functions because it's no state in a console function, never will be in these examples we're using, as far as I can tell. That's an interesting statement, isn't it? I said never will be, but maybe later on, and we just simply cannot see it, we would need to store some data related to the state of the console, for example. Maybe a more comprehensive console functions object would know what type of console you're dealing with. Is it a Python? Is it a Java? Is it a different version, etc.? So data and related to initializing these tools would be critical. That's up to you. What I would recommend is you go through, you build these, test them out, and make sure you're comfortable with them. At the moment, we're not storing any data. So to wrap up this, we are now showing you how to use objects. At the moment, we're not storing any data. We're just converting this into this, and then you're testing these out. You getting used to looking at this type of thing. Okay.